Hello, everyone, and welcome to FORVIA Talks. Only a few weeks before the CES, as you know, which is taking place in Las Vegas, right at the beginning of January 2024. So we're delighted to be here live from Paris. So my name is Asha Sampath. I'm a journalist covering sustainability and mobility topics, among other themes. So it's a great pleasure to be here. I know many of you are watching us live on LinkedIn, and some of you are watching us on replay on social media in general on different networks. So feel free to send us your questions, because we will be having our guests who are already here with us. We'll have the pleasure to take them in the second part of the program today. So let me begin by welcoming them. Actually, you are welcoming us here, because thank you, Patrick, for having us for this program. And we also have Christophe with us. So Patrick, you are the CEO of FORVIA, and Christophe Offray, you are the CTO of the company. It's great to be with you.
Hello, Asha.
So we start straight into the topic matter, like I mentioned earlier. So a few weeks before CES, so lots of excitement around that. And I know there are lots of expectations around the technologies that you're showcasing there, but also to speak about a major theme that is affecting the industry as a whole is decarbonization.
I think that climate change is disrupting completely our industry and our business models. And this is, an opportunity for all of us. It will give us the opportunity to demonstrate the agility of the industry and how quick we can be in order to transform ourselves. It's, I think, the biggest revolution in modern automobile industry. It's touching everything. It's not only touching the drivetrain, the powertrain. It's also touching all what we do inside the car and how we will use the cars.
Right. And one of the things that I've read is your mission statement, which is very interesting, where you say that you pioneer technology for mobility experiences that matter to people. I will focus on that part, what matters to people. So how do you take into account what really matters to people?
What counts is maintaining freedom of movement while respecting the planet. And this is a human right that needs to be accessible to all. And this is why that matter to people is critical for us. We've seen that we have an inflation of the vehicles and the mobility costs. We want to make sure that we are not producing vehicles, or that we're not contributing to produce vehicles which will no more be accessible to the majority of people. And, these different technologies could contribute to the inflation. And what we have to do as engineers is to find solutions which will avoid this. You know, we have to be creative. Maybe we will have some components, like some materials, which might be more expensive, but we have to find solutions in the system integration to compensate these costs.
And I know that there's this huge ambition from the group actually to reduce GHG emissions on a quite a large scale. And actually, I think you're one of among the first companies to have obtained the SBTi certification. So you want to be a pioneer there?
Yeah, I think that you see here on the slide that we have a few targets and also milestones. The first one is related to the scope 1 and 2, where we are committed to become neutral in 2025. The second milestone is 2030, where we want to achieve minus 45% CO2 on scope 3. And the last one, which is the net zero, SBTi validated in 2045. Maybe one thing, and this will be, the tagline of our CES demonstrators. It's designed for scope 3.
All right.
The reality, when you consider our target for 2030, we have 6 years in front of us, a maximum of 2 vehicle generations, and in this time frame, we have to achieve these less than 45%. Yeah? And we will show the different technologies, we will show the different architectures, we will show the different materials we might use to achieve this target.
And what about today? Where do you stand today?
Today we have made already a certain number of achievements. And if I take the first one, the scope 1 and 2, we are 1 year ahead of our schedule, and we will make it happen. So we will be there in 2025 with a reduction of our CO2 by more than 80%. Maybe just a reminder, when we speak about scope 1 and 2, we speak about energy management. So the energy we purchase and the energy we consume. Yeah? And we have to work on both. On one hand, controlling the energy consumption and doing whatever we can in order to reduce it, and we are reducing it by more than 30%. And on the other hand, buy green energy, and this through PPAs and through renewables. We are buying around the world, and we are also equipping our roofs with solar panels in more than 80% of our plants.
All right, and also acting on scope 3, like you said earlier. So, but what are you actually doing to maintain this decarbonization trajectory, if I may say?
So, first of all, scope 1 and scope 2, that's something we are in the process to achieve, and I think that's going on track. But it's only 3% of our total emissions, which are representing about 37,000 kilotons of CO2. So it's a big part, the scope 3. It's the biggest part. And in this scope 3, you also have, counting for 65%, the use of the vehicles. In this case, we are helped by the electrification. More electrification will grow, battery electric vehicles and new energy vehicles, and better will be, or reduced, and even more reduced will be our CO2 part related to this one. And we have about 32%, you see it here, which really are in our hands. And when you look at it, you have about 50% of this amount, which is related to what we buy and what we produce, is the remaining part. So we have to work on both. We have to work on both, and I think you will be interested to see what we have already achieved and what we are capable to demonstrate in Las Vegas.
I think there are two questions here. So how do you convince actually customers to buy more virtuous products, and on the one hand, and how far can you've got today with the scope 3 reduction, which is, like you said, still work to be
In
done?
fact, we do not have to convince our customers to go ahead in this direction because, we are working for the same consumers. And the consumers are more and more concerned about climate change. And they are also much more prepared today to use recycled materials, biosourced materials, to understand that weight is an enemy, and we are working all together. Now, it's what I said before. We cannot afford to have increases of the final product. And so we have to find solutions in order to make it affordable while significantly improve the CO2 performance.
And it's the use less, use better, use longer. So those are, of course, the scope where you want to head. But what can you say? What are the biggest lever that you need actually to pull to reach this quest of scope-free reduction, which is the real topic here?
You will understand that using recycled material is not cheaper than using virgin material. In fact, it's the contrary. Biosourced material is the same thing. Yeah? And when you combine these materials for new formulations, you are structurally increasing the viability of this material, which you need to get compensated through the transformation processes. And so here you are using AI, you are using new technologies in order to make sure that the transformation will be possible in the best possible conditions. For example, if you inject plastics, you have to do it at the minimum of the tolerance, in which case the parts are lighter, which is important, but also cheaper. Yeah? You need also to think about how many components do you really need. Can you think about a different architecture? Can you think about different solutions which will reduce the number of components? And again, the weight, maybe even the packaging. The feedstock is also very important. You see it here because we are dealing with huge volumes around the world. So we have to make sure that we will be able to supply our customers with the expected volumes. The energy, we are doing also electronics. We have to consume as less energy as possible on the product side, but we also have to use as less energy as possible on the process side. Use longer. We have also to consider the circular economy, not only the recycling and the biosourced materials, but also the reuse. Yeah? And I think the combination of all of that is the recipe to reduce on an affordable way the CO2 performance.
And this will lead you to where you want to go.
Reduce the CO2 performance, no, to reduce the CO2
emissions and get to the performance you're looking for. So this is a huge challenge actually to get to. You mentioned the controlled part and the uncontrolled part. 65% is a lot when we look at the total emissions we're talking about. And now maybe what kind of solutions or products do you have to meet these commitments in real concrete terms?
We will see a few examples a little bit later, which will, I think, be explicit about how we are dealing with this. But clearly we have to consider, you've seen the diagram where we had the different components of the scope 3, the one under control and in our hands, and the one which is not in our hands. Yeah? So we have to work in practical terms on each of them. So we have to work with our suppliers in order to make sure that they do the same thing than we do, that they use the materials which will allow to improve the CO2 emissions. And again, we have to work with our customers and maybe even the customers of our customers to define the new conditions and maybe even specifications. Yeah? Because we are in the same in the same boat and we have the same targets. We are all trying and we have taken commitments about these emission reductions.
Right. And I'm sure that people who are watching us today are excited to learn more about the examples that you have to share with us today, Patrick.
Yeah. Christophe. No, I just wanted to make sure that you're with us.
Christophe is still here with us, and he's going to talk about in a few minutes about what's going on in terms of AI and digitization. So we'll get back to you, Christophe. So just maybe, I don't know if you have, you'd like to share some examples with us, Patrick, for Scope 3.
Yeah, so we start with them immediately. So we have here, the first one is the modular seat. The conventional way to build seats today is to do it in a just-in-time plant. So in fact, you send all the components to the plant, and you have about 120, 140 components you have to assemble in a given sequence to the customer. What we are considering here is to use modules, and modules which are very easy to clip together. So it means that we are winning a lot of time, and we are also dealing with single materials. So we are using one molecule, for example, for surface materials, for foam replacement or equivalents, and for injected plastics, which is making the recycling much, much easier. And you see here that on a seat like this one, we are able to reduce by 68% the CO2. Using 23% improved recycled materials, having a recyclability of the complete seat of 84%. And the fact that it is easy to assemble means that it is also easy to disassemble. Yeah? And it allows us, on the use longer parameter, to extend the life of this seat. You can replace some of the components. You can upgrade the seat with, for example, heating systems or even massage functionalities. Okay? So the next one is the sustainable headlamp. Here, the performance is even better. We have a reduction of about 70% with a significant weight saving. You see it, 60%, 50% of recycled materials. The recyclability of the full object is 90%. We are using even biomaterials inside. And we have an energy saving, this is what I said before, of about 60%. What is also very interesting with this one is the capex savings we are achieving. With these matrices, we are capable to define how we want to distribute the light on the road through software. And this is allowing us to respect the different regulations in the different regions and countries through the software, and not having to multiply the different headlamps.
Smart.
The full cockpit, you know, the full interior, when you see the number of surfaces we have to deal with, and the amount of elements we have to include, we are presenting a full interior and cabin with a CO2 reduction of 86%. With, again, 13% of weight savings. It's a little bit less, but we have to share that we are working on this now for a decade and more. Yeah? So we are permanently trying to reduce the weight. You see that the recycled material, the recyclability are very high. The bio material is also starting. It might also be interesting to speak about the fact that customers now, OEMs, are wishing to see that it is biomaterial. Yeah? So we have to find ways with our designers to show it while keeping the perceived quality at the best level.
So, yes, I was going just quick reaction on that. You were saying so using a lot of biosourced recycled materials, and we're also hearing about low carbon materials. So I know there are lots of materials you're working on. Maybe a quick word on that.
So we have created Materiact, which is our company in charge of formulating new materials. Yeah? So what they are doing, they are dealing with formulations, including virgin material, recycled materials, biosourced materials. Yeah? And this is exactly what I said. Through Gen AI tools, they are capable to assess the viability of these materials by batch, and they are then offering some support on the transformation of these materials to make sure that we achieve the right quality and the right weight of the parts being produced. Very importantly for Materiact is the feedstock. Yeah? And what is also a little bit special with this new activity for us is that we are now dealing with agricultural partners, completely different from the automotive industry. Exactly. And nothing, that's maybe one additional point which is valid for most of the things we spoke about, we are not able to do the things alone. Yeah. We only can do them inside an ecosystem, and the performance of the ecosystem will finally make the performance of the business you are selling to the customers. And I think that this is critical. So we have our engineers, our PhDs in Lyon, in the middle of France, and we are not starting from scratch. Yeah? We have an experience which is more than 10 years old now. We have started with what we call naphthalene, which is ham, and this is now present in more than 9 million vehicles. Yeah? So it's a very nice activity. We are also working with Plastic Odyssey, which is
yes, absolutely.
Comment dire, NGO. And a little bit more than that. It's also
they work on
startup.
Plastic waste. Yeah.
They work on plastic waste globally, internationally. And what is interesting is that they are checking how people, modest in most of the cases, are transforming waste into new products. Very often they don't do that for the planet, they do that for surviving.
Economic.
Yeah? But it's interesting to see with which kind of frugality they create value. And I think that this is inspiring for our future business.
Oh, fantastic, Patrick. And now this leads me to turn a little bit towards Christophe. So Christophe, I think we got the first part with Patrick, and the question is how do you get there? So in this second part, let me just probably remind the audience that you can start pushing your questions, and we'll get back to them right after this session. So Christophe, in the second part, I understand that the use of digitization and AI in your operations, Patrick already mentioned Gen AI. So can you tell us about the use of AI to integrate recycled plastic and bio-based materials into FORVIA compounds? How do you do that?
Thank you, Asha, for this good question. First of all, I don't know if you cook at home, but I will do the parallel with cooking.
Okay.
When you cook, you have a recipe, and you have ingredients that you need to take with the right proportion, that you need to blend, and then you cook it, and then at the end you have a good taste and a good behavior and a good flavor, I would say. This is what we used to do within what we do with compounding, so having the virgin material, blending them, and then injecting them to get a part. In the future, it will not be like that. We'll have to do, as Patrick said, with not only virgin material, but also bio-based materials, and other kind of materials like recycled materials. And so we don't have the stability on that, we know, and we have at the end to have the good product. So we need to deal with the variability of all that. And for that, we need to use artificial intelligence. What does it mean? It means that we are going to use this artificial intelligence to predict what will be the behavior of the blended material ready to be used after that in an injection machine, for example. So this is very important for us, and we have to train our models, and we are doing more than 300 kind of formulation for that. And then after that, we are able to predict what will be the behavior of this material.
All right, but you to be able to do that, you need data.
Yes. So this is why we test the material at the beginning. We test the recipe that we get, and in the end, so from that we use the artificial intelligence with the mathematics and so on to know about some clusters where we can use. After that, we know that we'll be able to use those materials for our products.
Christophe, without going into really technical details, but very, very brief overview of the steps, that you're doing these transformations. How do you ensure the robustness and reliability of these predictive models? Just very briefly.
So we use, of course, different steps for that. First of all, we need some data scientists, for sure, and we've also chemist people, because we need to work together. And this is key at the beginning. So we need very high level of people like that. After that, we have a progressive technology starting with virgin material. So we have used virgin material to test our different models. So we were able to do that and to demonstrate that it was possible. Now we are integrating recycled material. We do the same. And at the end, we also need to take into account the process variability of the machine, which is the compounding machine in the end, because you have also some variability within the process of the machine. So this is what we do. This is the second step, and then there will be the first step also with bio-based materials. And with all of that, then we are progressing and delivering the right level of quality so that we can use those materials for production processes.
Right, very interesting. So after formulation, there are other benefits, I'm guessing. I don't know if Patrick, you want to jump in, so feel free.
I think that AI is allowing us to reduce testings, enlarging the tolerances of these different materials. It's allowing us to win time, to use different recycled materials from different origins in the same formulation. So it gives us much more flexibility. It allows us to be less restrictive on the feedstock. And very importantly, it allows us also to make the link with the transformation process. I think what is here specific is you have on one side the material, but this material will have different structural variabilities. And so when you supply this material to the people who will transform these materials, they need to understand that, and they also have to understand if their processes is able to cope with this structural different variability. And we make the link, okay? So we know what are the processes which will be used for the transformation, and we are able to calibrate the material to make it possible. And here again, we need a lot of AI to make sure that this will work.
So if I understood, it is completely transforming your operations. I mean, AI and digitizations for you from
yes, so from the material to the different processes, as we said before. So we have the initial material, then we need to inject it. So we use injection machines. And within this injection machine, we are going to master, to check every kind of data that we can have. For example, the cycle time, the temperature, and so on. And as Patrick said before, we want to, for example, to inject less materials, as less as possible material, to have less weight, and to be also more and more affordable, for example. And this is what we can do if we can benefit from all those data and we can analyze all those data. Then, if you follow the production process, that at the end, for example, we are going to have some kind of a computer vision on our parts to detect whether there are scraps or not, to be able to have the good quality control in the end. So this is also with artificial intelligence, for example.
Do you have some? Yes, Patrick, go ahead.
Just one thing, because I was thinking about your question and about AI. I think when I look back, what are the main transformations we went through and which are still ongoing? We have, first of all, a shift from west to east of the automotive industry. Then we have a very significant, quick growing content of electronics and software. Very soon, electronics and software will represent more than 50% of the vehicle value in 2030. So it's tomorrow. We also have, the transformation related to the climate change. We spoke about that on the drivetrain, but not only. We spoke about Scope 3. And now we have the Gen AI transformation. Yeah? And this will be, again, a very significant disruption of our industry, but not only. I think that many different industries will have to question themselves about how it works. The main aspects, it will touch the global company completely transversally, but we are concentrated in the moment on R&D and on operations.
All right. And I have 2-3 more questions for you, and then we will take your questions. So we count on you to start sending them. And I have my iPad here. Hopefully, I will receive them straight away. So, Christophe, a few examples maybe on how these technologies are being implemented, at FORVIA on a regular daily basis.
So this is what we talked about before. So within the R&D, of course, we use that also to generate design, I would say, but also for the production system, of course, within our industrial capabilities. So as I said, for each kind of machines, we use artificial intelligence, we use predictive models up until the predictive maintenance, for example. So on the injection machine, on the assembly of the parts, then on the checking of the quality at the end of the line, plus the predictive maintenance and so on. So at each step, we use the artificial intelligence.
All right. And in terms of financial impact of these innovation, in particular, how is AI optimizing the business? Maybe just a few words on the business perspective.
You are, again, save time. Yeah? Today, the average or the used time to develop a vehicle, I'm not speaking about all the pre-developments, is about 36 months. Yeah? A company like ours is capable to develop all its products currently in about 20 months. And I think that this will be even shortened significantly using Gen AI. That's one thing. Second thing, and why? Because the simulation tools will allow you to have a design much more robust than previously. You will have less testing periods and validation periods. You will have a quality which will be also more robust, more stable than before, and you will save a lot of hours in the design. Okay, so multiple improvements have to be considered. And I think of course, and you spoke about that, you need the data. Without data, no AI. Yeah? And the optimum will be achieved if we find the right way to make humans and the machine collaborating efficiently.
Right.
Yeah? Because we will need our expertise at least for a starting period, and I think even after, even if we will have to train the people. So it's we will see different métiers, we will see different organizations, we will see different setup also geographically, but it's something you have to accept,
right,
because what is at stake is huge.
Maybe, Christophe, we finish on this one. I know that FORVIA has won at a couple of awards at CES 2024. Maybe before we take the questions of the audience, I know, just tell us a little bit about these awards and what are they?
We can see them.
Maybe we're going to see them on the screens, right? So I think they're quite related to safety and sustainability.
Maybe on this video, because we had the video running. You saw one of our plants.
Yes, absolutely.
And the idea here is to work as much as possible without operators, which is possible. And so we have these pilot plants in the different métiers of the group in order to understand how we will organize and how we will architecture our manufacturing facilities in the next future. And you have here a video of real life. This plant is producing every day, supplying our customers. So it's not, the future in 10 years.
Right.
It's now.
Yeah, absolutely. And we can see, can you comment that properly for us, Christophe?
So the first one is what we call a flat light. So it's a very interesting solution because it's very flat. So you know that each time you can save 1 centimeter, you save around 2 kilos on the car. And with that, we can save some half of a centimeter. So it's important. We can also save energy, 80% less. So flatter, more packaging, better packaging, things like that, and better efficiency globally. So this is why we got this first award. And you can see that we can have some different colors. We can use also some LCD system to also display something on that. So it's a real interesting solution and very disruptive, I would say. So you see different colors. So the second one is about, it's coming.
It's coming up, yeah.
What we call the Skyline immersive display. So you can see on the top of the dashboard, fully pillar-to-pillar display with a driving experience, which is interesting because you can see the road at the same time as you see the information, for example, and you see the quality also. So it's no more a black display; it's something which is animated, and you can put whatever you want on this bar, I would say, of display. So it is very interesting, very convenient, and for safety, I think it's very good also.
And I think there are two more.
Two more, yes. This one. So we are very interested to show that. So it is what we call e-mirror, but you know some e-mirror. So it means that instead of having a normal mirror, you have an electronic mirror. So with a camera to see what's going on behind you. But with this innovation, you see that you can make the car more transparent in the end. So you can see through, as you see here, through the car. So it means that you have more or less 180 degrees view on the rear of the car. So you increase the visibility, of course, and the safety around that.
This is perfect.
And of course, the comfort also, the view comfort, I would say, that we use when using this e-mirror. So it's a very attractive solution.
And I think there's a final one. Yeah.
There is a final one which is called a light tile for transparent door. So you see that sometimes you have on the pavement, on the road, some cyclists, objects or movable objects that you don't see really. So with that you can see throughout the door panel. So you will be able to see someone coming on your right or on your left through the door panel. So it's an innovation, of course. And of course we can improve the safety for all those different users of the road, I would say, which are not vehicles, I would say.
So we are proud this year to have won these 4 CES awards, and I take this opportunity to thank all our teams who are working hard to innovate every year and to allow us to have new demonstrators at each CES. And I'm sure that this year will be again a good year for our customers and for our visitors.
All right, brilliant. So 4 awards, but many more innovations to show at the CES, obviously. And probably let me seize the opportunity to take the question that we've received here. So what do you expect from this year's edition at the CES? What are your expectations?
I hope that we will be back to the CES we knew in 2019, 2020. I hope that the Asian visitors and the Chinese will be back. I hope that our customers will also come to the CES. We know that some have decided restrictions, but the number of visitors, the quality, of this environment is making the full interest of the CES, and we have all to work together to keep the attractiveness of this event.
All right. And next question, do you think that hydrogen mobility can really take off?
Yes.
I knew your answer, so but maybe some more flesh in the bones.
I think you have key advantages of hydrogen. The first thing is the fueling time. The second one is the autonomy, the range you can achieve with hydrogen. And the last one, which is maybe less used, it's the payload. When you think about light trucks in America, if you want to electrify them with using batteries, you will increase very significantly the weight of the vehicles, and the payload will be consequently reduced. On the top of that, you will also lose space for storage. Yeah? And so we believe that especially for light trucks, as much as for light commercial vehicles, but also for the heavy mobility, hydrogen is certainly the best technical solution. Now, what we need to do is to converge from a cost point of view, because the volumes are still small, and so we need to grow. And the target should be, in 2030 by the latest, to have a full hydrogen system at equivalent costs than the battery pack for the same range, of course, and for the same power.
Maybe, Patrick, if I may, we have also two solutions for the hydrogen. We have the fuel cell stacks, as we said, and we have also the internal combustion engine, which can be fed with hydrogen. So we use a conventional, I would say, engine, and then you inject hydrogen instead of injecting gasoline inside. So we have two possible solutions. There is maybe one which is more short-term, which is with internal combustion engine, and the other one also. Both will have a market.
In fact, all the zero emissions or the ultra-low emissions are based on hydrogen. It's also the case of e-fuels, for example, for which you need hydrogen.
Do you have to talk with your customers about lowering requirements of the specifications to design sustainable products and system? I don't know if that was clear. Talk with customers about lowering requirements of the specifications to design sustainable products and system. I don't know if you get the point.
I take an example of an Gen AI application. In the frame of an RFQ, you get from the customers a significant package of documents, specifications and also specifics to an application. With Gen AI, you can read them and analyze them very quickly. And you can easily compare them with competition. You could also compare them with what you believe makes sense from a set of specifications point of view. So we will be able now quickly and with the right quality of data to support our customers with maybe some specification challenges, especially if we believe that it will trigger a significant saving. And I think that this is our role. It's our role to manage the things that way.
Yes, there are possible some compromises on that. For example, when we speak, and Patrick spoke about the visible sustainability. So it is accepted now to have the perfect surface, because if you want to see the sustainability, you need to see some issues that could be an issue, which are not issues.
There's more acceptance.
That was not possible before, for example. So we can compromise on that. Sometimes on some other specs as well, because as Patrick said, when we use Gen AI on all the specifications of a car, then you have contradictions sometimes between the specifications. So you can use that also to propose something different in the end. So these are just some examples.
I'm saying it again, affordability is key. So we have to find together ways to make the vehicles cheaper.
A question on EV cars. Have European manufacturers already lost the battle of EV cars against China? I think you can bring some insight here. I mean, the question is I don't know if we can say the way it is put, but I'm sure you have your own understanding of the question, Patrick.
I think that we have some handicaps. Yeah, the main materials which are used to build the batteries will come from China because it's where these metals mainly are refined. Yeah? The second issue we have in Europe is the cost of energy. Yeah? It's 3 times cheaper in China and close to 4 times cheaper in the US. Okay? So we have to overcome all of that. It's not easy, yeah? But we will have to find ways to make it happen.
The battle is not lost.
No, I think the battle is not lost. We have, we have a long history, but it will not be an easy one. And I think again, creativity and all of the other aspects. We spoke about Gen AI, we spoke about the materials, we spoke about many other transformations which are ongoing, and you have to consider everything. Finally, the product you are selling as a whole. We also see, in China that the things are improving very quickly, and that the challenge is a real one for all the players around the world.
There's a question on naphthalene. In which car models is it actually used?
It's mainly used in the middle segments. Yeah? It's not in the premium, and it's not only in the very low segments.
Yes, if you take cars like the 308 for Stellantis, for Peugeot, or Megane, things like that. So this kind of C segment, as Patrick said, family cars and so on. So here it is implemented.
One way to reduce emissions is to produce less. Is this part of your strategy and business models?
To produce less, what do you mean? Less vehicles?
Less production in general.
No, I think that here we would speak about philosophy and maybe not about the automotive industry. The big issue we have is the CO2, the stock of CO2. Yeah? So if you produce less, you will emit less, which is a good thing, and we have to deal with this all together. But it will not eliminate or reduce the stock of emissions you have. And so what we believe is that the solution will come from innovation, research, innovation, and industry. Yeah? We are the ones capable to deal with this problem. We take very seriously. We take it with a lot of convictions. We are contributing to that, and not since yesterday. Yeah? And I believe again that, I said it before, but this again is one of our very strong convictions. Mobility is a human right. Yeah? And so we have to respect that, and we of course need to make it. We need to design solutions which are good for the planet and affordable and accessible to all.
This one is about I think it's a more personally, you can answer in a personal point of view. So what electronic device is inspiring you to create innovations for cars? I don't know if...
what electronic device?
What kind of electronic device is inspiring you to create innovations? Are you inspired by other things to create your innovations? I think we can take the question from that perspective.
I think that what is happening in the moment is that we have different electronics and softwares. We have the ones which are making all our products smarter, which we call the embedded software. So it's adding functionalities, is reducing energy consumption. It's allowing data collections or data which can be used in other domains. You have a software as a service where we are providing apps, GPS, buying over the air, and so on. So we have a lot of these possibilities. And finally, we have the system management. So we have the different sensors, actuators, and we can link them together through electronics and software and manage a more efficient system performance. Okay, and I think that all of this is contributing to make the car safer, to increase the use cases, even for people who today might not be allowed to drive. So it increases the mobility possibilities. Yeah, it needs to also work on reducing costs. In many cases, we can save parts. When you electrify, for example, brake pedal, when you make it by wire, you eliminate the hydraulic behind. So we have a lot of examples where we make, in fact, the car less complex system. So after that, we have, of course, all this autonomy or the support to the drivers to make their trip more comfortable. And I also believe that we will be able in the future, through upgrades over the air, but maybe also hardware upgrades, to prolong, to enhance the life cycle of a vehicle, which again, will make it more accessible to people.
So you're more inspired about what people are expecting from the car brand devices themselves.
Yeah, but also what we believe is that we have to keep, we need to be reasonable and pragmatic. Okay, it's not an race for engineers to show their capabilities.
Right.
It needs to make sense. Yeah,
to solve
that matter to people. I think that this is absolutely critical. Yeah, not technology for technology.
Christophe?
Yes, so the automotive industry will inspire also the other industries. But to answer your question, yes, we were inspired also by the smartphone also. Because yes, what we want to achieve is what the smartphone has done before. So it means an architecture where you can add some new functionalities, as Patrick said, upgradability, updatability, and so on, with a central computer. And this is what we call the software-defined vehicle that we are going to apply, and we have started within the automotive industry. So we will follow the same kind of architecture with a lot of benefits, so that in the end it is not a fixed, I would say, architecture. It is an evolutive architecture.
All right. I will take this one is on weight. There are two questions actually on weight reduction, so I'll try to go through both. So the first one is weight reduction a sale argument for America and China? And the second one is, what about drastic weight savings in vehicle? Should this not be a really strong direction where you should be headed?
Weight is critical for everything. For if you have an electric car, it allows you to increase your range. It reduces clearly the emissions of how you have built the car, but also in the use of the car. And I believe that in some extreme cases, it becomes an issue. If you have a big SUV, which weight is 2.5 tons and more, with an urban cycle of about 50 kilometers a day, does it make sense? So when we are serious about the climate change, we are regulating, we are forbidding in Europe to use ICEs, but we cannot replace that by SUVs with this level of weight. Okay, so I think that it's a key element, and it's use less, and the use less is a fundamental principle. And I think that this we have a clear consensus on this item with all the players.
So we see that the batteries, the size of the battery is increasing, as Patrick said. So this is an issue. You have to compensate at least that, which is not achieved today. So we need to work a lot on weight saving. So this is a real important topic for the industry.
All right. A couple of more minutes, but I think we have time for 2 questions, and then we conclude. Maybe I will take this one. What is the technology that you're the most proud of, the technology symbolizing the most your commitments, your strategy? I don't know if you have something like that, or it's a combination of what you're doing.
There are technologies you see, because you touch the product or you have the functionalities. But you have a lot of technologies you don't see, which are the processes we use to manufacture the different elements. And I can tell you that sometimes I'm more impressed on the equipments we are using and the way we are getting organized to produce versus what the functionality is. So I really can't give you one single answer. What is for me impressive, and this is an argument to join the automotive industry. Everything you have in a car has a significant technology content. Everything. And I do not believe that there is in other industries an equivalent. We are a heavy industry working on a B2C mode. And we are delivering reliable, sophisticated products, still affordable. They should be even more affordable, but still affordable, okay? And this needs a lot of passion and a lot of competence and expertise in all the domains.
Maybe this last one, what car manufacturers are the most impressive in terms of innovation, according to you? That's a question both of you. Christophe, without making any promotion for anyone.
We have the newcomers on one hand, the Teslas and the others, which are not shy in using new technology. And when we want to apply our new technology, sometimes we go to them. And we have also, of course, the premiums that we know in Germany, for example, but not only, who are using also the last technology to make a difference versus the other. So we work with both. After that, we have, I would say, in the middle, some kind of clever, I would say, customers. They don't have the money to use very high-level technology, but they want to be innovative. And those one is more a clever solution, smart solutions also. So we have those 3 different kind of customers.
Smart answer, Christophe. Patrick, maybe we have, I think, 2 minutes left, but maybe just maybe you can touch on the question and just your final conclusive words for our audience watching us today.
So maybe you understand that our ambition is to produce smart solutions, affordable solutions, reliable solutions from a quality point of view and from a perceived quality point of view, individualized, so that we are responding really to the expectations of the end consumers. But again, for me, the most important and conclusive point is what matters to people.
So we'll continue to keep an eye on that. So what matters to people? Thank you, Christophe, and thank you, Patrick, for your time. And thank you to all of you for your great questions. So it was a pleasure to have this conversation together. Thank you very much. And probably see some of you at CES this year. I don't know, you guys are going to be there. So thank you very much. And we continue to keep an eye on the latest tech innovations in the industry. Thank you very much. Thank you, FORVIA teams. And thank you. Until next time, goodbye.
Thank you.
Thank you.